All right, last one of the day, parallel and perpendicular lines from equation. They want to know if these lines are the same line, parallel lines, perpendicular lines, or just normal intersecting lines. This is, we'll talk about it. How do we know? Well, let's take a look at the equations. Well, the very first thing that I notice about these two equations is this bottom one is what I would call reducible. All three of those numbers are divisible by 4. So if I divide everything here by 4, this gets divided by 4, this gets divided by 4, and this gets divided by 4. What is yielded is x, because 4 divided by 4 is 1, plus 3y is 5. And therefore, I have the exact same equation. So this is clearly a case of the same line. All right, now this one. Now, what they've done here is they've given us a couple of different ways to look at this. They've put it in two different forms. They have one form is in point slope form and one is in standard. Now, again, I do notice right off the bat that this is reducible. So before I do anything, I'm probably going to reduce it. So I'm going to divide everything by 2. So that's x plus 3y equals 12. Now, because this one is in point slope form, I know a point and I know my slope. So I'm going to see what my slope of this line is. That's going to be my first step. And then that's going to at least tell me if they're the same line or if they're parallel or if they're perpendicular. I'm going to know that pretty quickly. Well, they're going to tell me it's potentially they're parallel or they're perpendicular. And then I'll have to do one more thing to make sure. If they're parallel, I'll need to check and make sure they're not the same line. Okay, so first things first, how do I find the slope? Well, the easiest way to find the slope is to put it in slope-intercept form. So you start by moving the x to the other side, and then you divide by everything that's in front of the y, which is dividing everything by 3. And so I get y equals negative 1/3 of x plus 4. Now, they have the same slope. They both have a slope of negative 1/3. So they're at minimum, they're parallel. Now, I need to make sure they're not the same line. And how I do that is the point that's told to me here for this line is the point 15, negative 6. I need to make sure that point is not also on this line. Because if they're both on the same, if it's the same, and by the way, that's not a y, that's a 4, by the way. If this point is on this line, then they're the same line. If it's not, then they're parallel. So I'm going to take 15 and I'm going to plug it in. So negative 1/3 of 15. Negative 1/3 times 15 is negative 5 because 3 goes into 15 5 times. Negative 5 plus 1 is negative 1. So when I put in 15, I get out negative 1. I do not get out negative 6. So therefore, they are different lines. They don't go through the same point. So this is clearly a case of distinct parallel lines. All right, the next one. Now again, they've given them to me in different forms, but these are actually kind of convenient forms because on both of them, they've told me the slope. So the slope here is 3/4. This is slope-intercept form. This is point slope form. My slope is 4/3. That's great. They've already told me my slopes. I know they're not parallel because they're not the same slope. The question is, are they perpendicular? And they're close, but they're not. They are not. They are reciprocals. That's 3/4. That's 4/3. But they're not opposites. So they are both. They are reciprocals, but they need to be opposite reciprocals to be perpendicular. So this is not perpendicular. This is going to be intersecting, but not perpendicular. Now, how do I know they're intersecting? Because they're not parallel. If they're not parallel, they have to run into one another. So then the question is, are they perpendicular or not? These are not. If that was a negative 4/3 or that was a negative 3/4, they would be, but because they're not opposites, they are not perpendicular. Last one, again, super nice here. They've already told me my slopes. Because it's in point slope, this is point slope, and this is slope intercept, they've already told me my slopes. And this looks very similar to the last one, okay? So this one and this one are indeed reciprocals, and one of them is negative, so they're opposite reciprocals, so they are perpendicular. Now, by the way, I don't need to check the point because they're going like this. So obviously they can't be the same line. They don't have the same slope. The only reason you have to check that one point on the parallel ones is because they can be going like this or they can be laying on top of one another like that. And so you got to check to make sure they don't go through the same point. You don't have to do that with perpendicular. These are clearly perpendicular lines. All right, guys. Have a great long weekend. And unfortunately, like I said, if you paid attention to the weather, Monday we might be getting some more snow, which could definitely throw Tuesday, and then Wednesday apparently is potentially going to snow again. So next week could be kind of hairy too. Um, but if we continue doing these remote days, everybody knows what to do. You're going to see my face on some videos, and I'll post some stuff. And again, if you ask questions, I'll make more videos and post those too. So have a great long weekend. Hopefully see you on Tuesday, but we'll see.